So thank you for the introduction. So I'm Hisashi Nishikawa from Ritsumeikan University from Japan. I'm today presenting the method to detect very small capacitance variation, such as 10 attofarad level. Maybe you are familiar, but 10 attofarad is milli, micro, nano, pico, hemp, then attofarad. So it's anyway very small capacitance. We use a VHF oscillator for the detection. I'll go detail from now on. Okay. So we applied this detection system to detect the pest inside of the wooden post, such kind of the white ant. So white ant causes a catastrophic damage to the wooden house, so some prevention is necessary. And problem is that we can't see the pest from the outside, especially for the initial stage. And we cannot cut down the actual wood, so some detection method without a physical process is necessary for the prevention. Okay. Previously, some radar system using a microwave or acoustic monitoring, such kind of monitoring the feeding sound of by the pest. So this process is available. However, the former one is a very expensive system. The later is only applicable when the pest is actually eating the wood. So some versatile and inexpensive and easy to use detection system is desired. We applied our capacitance variation detector to detect the pest inside the wood, and we got a successful results. I will show the detail. So basic theory. So we use inductor and the capacitor type and VHF oscillator. Left-hand side and the inductor there, and small sensing pad is attached to the hot end of the C. Okay, and another pad connected to the system ground. So resonant frequency of this schematic is shown by the typical formula in the left side. Okay. When a pest coming close to the sensing pad area, the pest had a higher epsilon compared to the normal air or dry wood. So capacitance must be increased slightly. As a result, the oscillation frequency is going down accordingly. So the frequency delta is calculated by that formula. Okay. So sensitivity point of view, so this chart shows the horizontal axis of the capacitance in added, capacitance change, and the vertical axis is frequency shift. On top to we use a 98 MHz oscillator in this case, and so difference from the 98 MHz in the vertical axis. Okay, and the 3 points and is measured. This is actually measured, and by adding some small capacitor to the circuit. But we can't measure the 10 attofarad anyway. We can't make it. So the dotted line is the calculated value for the extension to know the sensitivity. So let's see, 10 attofarad is added to the base capacitance. The oscillation frequency shift is 300 Hz. In another word, if we can detect 300, we know 10 attofarad capacitance delta. This is the sensitivity of our system, of our target. Okay? But in this case, we use a 98 MHz as a resonant and the oscillation frequency. And we need 100 Hertz order accuracy or resolution. So we can count that by using the, for instance, instrument type frequency counter, but it's very expensive and it's not handy for the system. So we need some solution here. So we focused on the Superheterodyne frequency conversion system. So this system is originally used for the radio receiver or transmitter. For instance, 98 MHz signal is coming from the antenna, and going to the mixer through the amplifier. And the mixer has a fixed local oscillator with 100 hertz, 100 megahertz, given by the crystal. Okay, so because of the mix action, we can obtain 4 frequency elements. One is the original 98, and also the original 100. Then added 198 megahertz, and also subtracted the 2 megahertz given from the mixer. By applying the 2 megahertz low-pass filter, we can obtain only the 2 megahertz of the intermediate frequency output. Then this 2 megahertz is detected. Now we can hear the sound from the speaker. This is the typical diagram for the receiver. Okay, we focused on the frequency conversion action, 98 megahertz to 2 megahertz in this case. So remember, so 98 megahertz is a VHF oscillator for the sensor we have discussed. Then 98 megahertz going to the mixer, and we obtain 2 megahertz as output. Okay, this is the subtracted system, frequency conversion system. Key point is because of the subtracted action, the original 300 hertz delta, for instance, is still kept in the 2 megahertz, right? Because of the subtraction. So 300 hertz over 98 megahertz is 0.0003%, for instance, and the 300 hertz or 2 megahertz is 0.015%. In this sense, and it's magnified 50 times, just like the amplifier. And the 2 megahertz case, we can use the inexpensive CMOS counter. Even the microcontroller is good enough for the counting with 1 hertz level resolution. Okay, now, so utilizing those system. Okay, this is a actual example of the implementation. So left-hand side is the block diagram we discussed, and in addition, we added the 2.4 gigahertz transmitter so that we can monitor the frequency from the different locations. So right-hand side, you can see the oscillator. You can see the actual through inductor for the base inductance, and local oscillator, mixer, and a frequency counter, and a DC-DC converter for the power supply, and a 2.4 gigahertz radio. And rechargeable battery is also implemented. So actually, this system is made in this size, very small, very handy, and very cheap, I believe. So this is actual implementation to the pest sensing. And to the wooden post, the sensing module is attached with the sensing pad, 2 sensing pads. Okay, in addition to those sensing pad, and we applied some shield ring. You can see it in the left-hand side. Because of limited time today, I don't go into the shielding technique, but our sensing system has very high sensitivity. For instance, it is placed in 3 meters ahead, and I move my hand like this, the frequency shift about several hundred hertz. So that kind of high sensitivity. That means we have to isolate from the environment for the accurate detection for the pest itself. So for that purpose, based on our experiment, and a very small ring is good enough for such kind of shielding to isolate from the environment. Okay? So to the wooden post, a groove is made and covered by transparent plastic film, so that we can keep the actual pest inside of the groove. And video camera is attached to the groove and recorded with timestamp, so that we exactly know what's happening there. Okay. Okay, this is the actual setup photo. Left-hand side, the sensor unit, and it's attached to the wooden post. Of course, in the wooden post, some pests and kept there. And via the wireless connection, we have a receiver and connected to the PC through the USB. And the PC has a monitoring program which monitors the trend of oscillation frequency. Actually, we are monitoring the 2 MHz in this case. So this is one of the results. Okay, horizontal axis is time passing with 5 seconds per digit, and the vertical axis is the frequency shift value with hertz. Okay, and because this is a subtract system, 98 MHz going down by the Pest, that means the IF frequency is going up. So you can see 2 peaks there. This is actually 2 dips in the original 98 MHz. Anyway, you can see 2 peaks here, and with about 200 Hertz. So, and at about a 5-second time frame and the 25 time frame. And we confirm that exactly at this time, one pest is just crossing the pad area. So that means that we can successfully detect the movement of pests inside the wood from the outside without applying any physical process to the material. Okay, summary. VHF oscillator with a small resonant capacitance can detect very small capacitance, and which is applicable for the pest detection. And because there's high sensitivity, this is not only for the pest, but I believe it's kind of applicable applied to the sensor, human movement in the different position, and some animal detection sensing. And also the applicable for to detect a very small particle in some industrial machines. Okay, that's I prepared today. Thank you very much.